So, pesticides are used to target certain species or organisms and control them if they are harming life around them. So, if a certain organism isn't supposed to be there or is doing something to harm the life around them or the territory around them, pesticides are useful to make them stop doing that. But one thing is that sometimes pesticides get in and stop things that they're not supposed to, which is why they're harming life. So some examples of research that have been done are in this first graph on the bottom left. This shows research from the past 28 years on different pesticides and how they have gone up in trend in like pesticide effects, so like how they have affected things. And then on the other side, graph shows different species and what pesticides do to them and what the population has like been through with pesticides. So for instance, mammals, like it shows the immunotoxicity and it increased in the population. Also under that, you see for the birds the pesticides that are used, and then on the other side it shows reproductive failure as a result of the pesticides, and then death and a population decline. So that is why we're doing research on this, to prevent that.
So this slide is going to be on pesticides, the unintended effects on the individuals. So in the image, the table highlights the complex and interconnected nature of pesticide effects, ranging from individual level impacts to ecosystem level consequences. The sources primarily focus on unintended effects on pesticides on wildlife, particularly at higher level of biological organization. So in the image, it shows the pesticides can cause a wide range of adverse effects on individual organisms. Pesticides can have an indirect effect on wildlife by altering food webs. In the image, it shows the effects pesticides can have on individual organisms like neurotoxicity, altered metabolism, endocrine disruption, immunotoxicity, and developmental toxicity. So this next slide is on population level effects of pesticides. Pesticides have an effect on wildlife populations, including mammals, birds, reptiles, amphibians, fish, and insects. According to the last slide, the image shows that pesticides can impact population through direct mortality. Pesticide exposure can cause widespread deaths, resulting in mass mortality events. Increased mortality and reduced reproductive success can lead to a decline in population size.
A biological community is a diverse group of organisms that interact together by creating different relationships, some mutually beneficial, some predatory, and some in between. A biological ecosystem is a very similar concept, but now we are examining both the living and non-living components that make up a space. Pesticides have a great effect on both. We've been talking about how pesticides have both a direct and indirect effect on species and organisms. For example, oysters exposed to DDT, toxaphene, or parathion were more susceptible to fungal infections. And pesticides cause a decline in the pollen collecting efficiency in bumblebees, which in turn diminish the overall pollination services, which has effects through an entire ecosystem and a food web. Many ecosystems are delicate and can be massively affected by the smaller changes. Every organism affects another, which in turn affects another. Pesticides, minorly affecting one species, have the power to change an entire community.
Effects of global change on pesticide consequences. Pesticides and their effectiveness are impacted by climate change, including increased temperatures and precipitation changes. These climate changes can affect the metabolism and toxicity of pesticides. Examples of effects of global change on pesticide consequences was shown through an experiment done on the fungicide primethanol when exposed to realistic climate change comparable to summer conditions in Europe showed a decrease in lifespan and a lowered population growth. These pesticide effects, along with global change, can further impact the functionality of the ecosystem and sparks interaction problems for animals and plants. A possible solution for this problem is a change from the older, stronger pesticides to a newer compound.
Solutions. The most beneficial way to restore biodiversity is by reducing pesticide application. Some ways we can help with this is public advocacy. A lot of people have very, very close access to the internet, whether it's social media or just articles, and it's a very easy way to get out into the public. Long-term monitoring populations. Wildlife populations to track changes in genetic diversity and population dynamics in response to pesticide exposure. And we can also educate ourselves more on climate change, as climate change is proven to speed up pesticide degradation, meaning that farmers have to use more, leading to more chemical exposure for wildlife populations and ecosystems. We'd like to thank you for your time and hope that you either were educated or further educated in the impact of pesticides on wildlife populations and ecosystems.